Hello everyone and welcome to my channel Aptitude Club. So today in this session we are going to discuss LCM models. Now LCM, when we read it as a topic in the area numbers, LCM models refers to different types of questions that are being asked from the LCM topic. Okay, so there are four essentially fundamental LCM models and I'll take you through all these models in this session. I'll make another session for HCF models. So in LCM models we'll discuss four types, and in HCF model we'll discuss two types. So that will be the next session after this LCM model session. And if you have missed the previous videos that I've made on this channel and you're watching this for the first time, do subscribe and explore the Aptitude Club channel and let me know your views and comments on my videos, and whatever things you like or what kind of videos you want me to make. So do give your feedback and suggestions in the comment section, and that will encourage me to make more videos for you. So if you are new, do subscribe if you like my videos and the way I teach. So let's begin it today's session. The first model. Now this is multiple divisors but same remainder model. Now think about this. Let's look at this question. Find the largest 3-digit number which when divided by 3, 4 and 7 leaves a remainder of 2 in each case. So you would have seen such questions if you would have solved LCM questions before, and from the question it is pretty much evident why is the model named multiple divisors and same remainder. So the number here is getting divided by 3, getting divided by 4 and getting divided by 7. So multiple divisors. But in each case I am getting the same remainder. So multiple divisors, same remainder. So how do I solve this? Now let the number we are trying to calculate, let's say it be n. So my divisors are 3, 4 and 7, and if I look at the remainders, it is 2 in each case. That means n when divided by 3 will leave a remainder of 2 in each case. N when divided by 4 is leaving a remainder of 2. N when divided by 7 also leaves a remainder of 2. Now I'll give you a direct formula to solve such questions, but let's get into the fundamentals of how this formula is derived. Let us understand a simple division. Okay, let me take a random division and let's try and understand what is division basically. For example, I am dividing 28 by 5. So 5 times 5 is 25 and the remainder is 3. This is called as the remainder. This is the divisor. 28 is called as the dividend. And this 5 is called as the quotient. So whatever is divided is called as the dividend, which is 28. Or in our question it is n. Now what is dividing is called as a divisor. What divides? So 5 is the divisor here. In our question we have 3 divisors, 3, 4 and 7. Quotient is the number of times. Now let's understand this properly. Quotient is the number of times I can subtract the divisor from the dividend. Okay, it's not like whatever we write on the top. ऐसा बोलते हैं जो ऊपर लिखते हैं वो quotient है, but उसका मतलब क्या होता है? 5 is the number of times I can subtract 5 from 28. So 28 minus 5 times 5 I can do, and whatever you are left with, that is called as the remainder. So when I am subtracting, division is continuous subtraction. So I am left with 3. Now let's say I remove 3. So 28 minus 3 if I do, so I get 25, and this is perfectly divisible now because whatever was left I removed it, so now nothing will be left. So nothing will be left means it is divisible now. So if I try and replicate this logic in our question, I am getting a remainder of 2 in each case. So can I say n minus 2 will be divisible by 3, 4 as well as 7? N minus 2 will be divisible by all 3 of them, because whatever was the remainder I removed it, so whatever is left is divisible. Now if n minus 2 is divisible by 3, 4 and 7, let's try and think what kind of a number is divisible by 3, 4 and 7. Any number which is divisible by 3 is a multiple of 3. Same logic, any number which is divisible by 4 or 7 should be a multiple of 4 or 7. Now if a number is divisible by all 3 of them, it should be a common multiple of 3, 4 and 7. So I can think of LCM. So LCM of 3, 4, 7 is such a number which is divisible by 3, 4 as well as 7. But is it the only number? LCM is the lowest such number. Excuse me. But this is not the only number, the least such number. So that is why I'll denote it as k times LCM, where k is any natural number. LCM or any multiple of LCM. So I can write n minus 2. LCM of 3, 4 and 7 is 84. So 84k. So I'll elaborate on the 84k part. 84k can be 84, it can be 168, it can be 252, depending on what I am taking it as k. But any of these numbers will be divisible by 3, 4 as well as 7. So that gives me n is 84k plus 2. Now once I know the structure of the number, any number which is in the form, standard form or the general form 84k plus 2, when divided by 3 or 4 or 7, it is going to give a remainder of 2. Now after this point we can elaborate, and question may ask us the largest 3-digit number, smallest 4-digit number, how many such 3-digit numbers are possible, what is the smallest 3-digit number greater than 300, largest 3-digit number between 600 and 700. Any question like that can be asked. But our process of solving is this. So this we can generalize as a model which looks like this. If I have multiple divisors but the same remainder, then the number is given as k into the LCM of divisors plus the remainder. Now the LCM of divisors in this case is LCM of 3, 4 and 7, which is 84. So I get my number n as 84k plus 2. Now I'll have to figure out which number is the largest 3-digit number that will be in this form. What is the largest 3-digit number that I know of? 999 is the largest 3-digit number. Let us check it is in which form. So 84 times 1 is 84. So 159. Again 84 times 1 is 84. So 75 is the remainder. So I can write 999 is 84 into 11 plus 75, which is nothing but 84k plus 75. But I need 84k plus 2. I need a number which is in the form 84k plus 2. So how do I get plus 2? So from this I'll subtract a 73. So 75 becomes 75 becomes 2. And this 84k remains. So on the RHS if I subtracted a 73, on the LHS also I'll subtract a 73. So I get 926. So this is the largest number that is in the form 84k plus 2, or in other words whichever number is in 84k plus 2 form, when divided by 3, 4 and 7 leaves a remainder of 2 in each. So this part that we calculated is a normal calculation part, but understanding that it is 84k plus 2, that is the model. So whenever we have multiple divisors but the same remainder, this is how we solve this question. I'll attach a question at the end of this video. So try and solve the same question from model 1 and let me know your answers in the comment section. Okay. So hope model 1 is clear. Let us move to model 2. Multiple divisors, same negative remainder. Negative remainder. So let us first decode the question, then I'll explain what negative remainder is. Question looks more or less similar. Find the largest 3-digit number again when divided by 3, 4 and 7 leaves a remainder of 1, 2 and 5 respectively. So it looks like multiple divisors, multiple remainders. Why am I saying same negative remainder? So let the number be n again. So what are the divisors? If I look at the divisors, 3, 4 and 7, and if I take the remainders, it is 1, 2 and 5 respectively. 1, 2 and 5. So n when divided by 3 will leave a remainder of 1, n when divided by 4 will leave a remainder of 2, n when divided by 7 is leaving a remainder of 5. This remainder I'll call it as a positive remainder. Then what is a negative remainder? So let's try and understand negative remainder, concept of negative remainders. Now, negative remainders are something which are not conventionally used while like making a division, but it is definitely used to solve questions and understanding the remainders concept in a better way. So let us take the same example of 28 divided by 5. The normal division looks like this. But what if I do this? Now fundamentally this is not something we have done in schools. But then mathematically this is not incorrect. I can still subtract 28 से 30 subtract तो हो ही सकता है. Like we don't divide this way, but mathematically like incorrect तो नहीं है, because we deal with integers. So negative integers are also available. So 28 से अगर 30 subtract किया तो remainder is -2. This is called as a negative remainder, whereas 3 is called as a positive remainder. Now in every division this is possible. Let's take another division. Suppose I'll take 43 when divided by 7. So 7, 6, 42, remainder is 1. This one is called as the positive remainder that we typically follow when we divide. But 43, when I divide it by 7 and do this, so I get -6. This is the negative remainder. What is negative remainder then? Now going back to the principle of continuous subtraction, let's say the first example. As long as I'm dividing any number by 5, so 5, 10, 15, 20, 25, 30 and so on. As long as my numbers fall on these points, suppose I'm dividing 5 with 5, the remainder is 0, 10 with 5, remainder 0, 15 with 5, remainder 0. But say this number 28. So 28 comes somewhere here. So 28 is 3 more than a multiple of 5. So that is why the remainder is 3. I can also say 28 is 2 less than the next multiple of 5. So positive remainder is 3 and negative remainder is -2. Another way to put it is, while I am dividing 28 with 5, I can subtract 5 times from 28 and I'll be left with 3. If I subtract one more time, then I'll be left with -2. Or had there been 2 more, I could have subtracted it one more time. 28 के पास और 2 अगर extra होता तो वो 30 बन जाता and I could have subtracted one more time. Whatever you don't have is the negative remainder, whatever extra you have is the positive remainder. That is how we put it. And you look at something interesting. The modular sum of the negative and the positive remainder is equal to the divisor. Mod 1 plus mod -6 is equal to 7. So property mein I can write this, that positive remainder plus the negative remainder modulus if I am taking, I will get the divisor. This is property 1. And property 2, negative remainder if I am having, if I add the divisor, I'll get the positive remainder. In the negative remainder, if I add the divisor, I'll get the positive remainder. For an example, there is this number n, which when divided by 8 leaves a remainder of -3. This is the negative remainder. So what is the positive remainder? The -3 plus 8, I'll get 5. तो नेगेटिव को पॉजिटिव बनाने के लिए ऐड द डिवाइजर, पॉजिटिव को नेगेटिव बनाने के लिए सब्ट्रैक्ट द डिवाइजर. दिस इज व्हाट नेगेटिव रिमाइंडर्स आर. नाउ इफ आई टेक दिस कॉन्सेप्ट एंड अप्लाई इट इन दिस क्वेश्चन, divisor is 3, positive remainder is 1, so what will be the negative remainder? Positive remainder minus the divisor, 1 minus 3 minus 2, 2 minus 4 again -2, 5 minus 7 again -2. So I get this. So this looks like multiple divisors, same negative remainder. Again, if it is the same negative remainder, I can go back to the same principle. That was this. K into the LCM of divisors, and LCM of divisors here is LCM of 3, 4 and 7, which is 84. So I can write N as 84K plus the remainder. सेम रिमाइंडर होगा तो आई कैन यूज दिस मॉडल, डजंट मैटर सेम पॉजिटिव रिमाइंडर और सेम नेगेटिव रिमाइंडर. Model 1 was same positive remainder, model 2 is same negative remainder. So the negative remainder is minus 2. So basically n is of the form 84k minus 2. Now I need to figure out which number is the largest 3-digit number that is in the form 84k minus 2. Now in the previous question we had checked 999 is 84k plus 75. Now plus 75 को minus 2 अगर करना है तो minus 77 करेंगे. So this becomes 84k minus 2. तो यहाँ पे भी minus 77 कर लो. So 9 9 minus 7 2 9 minus. So the number that is in the form 84k minus 2 is 922, and that is our answer, because our question was to figure out the largest 3-digit number, and the largest 3-digit number which when divided by 3 4 7 leaves remainder 1 2 5 respectively is 922. I can rephrase this question as the largest 3-digit number which when divided by 3 4 and 7 leaves a remainder of minus 2 in each case, and I'll arrive at the same answer. So I hope it is clear. Model 1 and model 2, because model 2 looks like multiple divisors, multiple remainders, but you see there is a pattern. In a lot of books you will see इसका एक pattern दिया होगा कि whenever the difference between divisors and remainders is same, so you do this subtract LK into LCM of divisors, subtract the difference. But why subtract the difference? I hope it is clear. Understand the why part. Here the difference in each case is 2. That means the negative remainder is minus 2. I am not actually subtracting, I am adding the negative remainder. Conceptually we should be clear कि क्यों subtract करना है. So sometimes in books it is written directly, if there is a difference between the divisors and remainders, then वो difference को LCM of the divisors से subtract करना है. But क्यों subtract करना है, we should be fundamentally clear on that part. So that is because of the inclusion of negative remainders. So it's the same model, but negative remainder आ रहा है, तो it looks like we are subtracting. Okay. Then the third model, multiple divisors, multiple remainders. So find the largest 3-digit number which when divided by 3 4 and 7 leaves a remainder of 2 1 and 3 respectively. So let the number be n. So divisors and the remainders. When divided by 3, the remainder is 2. It is positive remainder. If I am writing the negative remainder, it is minus 1. When divided by 4, the remainder is 1. Negative remainder is 1 minus 4, that is minus 3. When divided by 7, the remainder is 3. Negative remainder is 3 minus 7, that is minus. You see positive remainders are not same. Negative remainders are also not same. So it's purely a multiple divisor, multiple remainder question. So that is model 3. And here we will use this technique called as Chinese remainder theorem. Not any formula, it's just a process. So what is the process? So what I'll do is, step 1, I'll try and club the divisors and remainders, and I'll start with the highest divisor. Now understand there are three properties of n. N when divided by 3 leaves remainder 2, when divided by 4 leaves remainder 1, when divided by 7 leaves remainder. So there are three properties. So I'll try and filter out one step at a time. Okay. Why start with the highest divisor? ऐसा नहीं कि तुम कोई divisor से start करो, answer आएगा ही आएगा. To start with the highest divisor, you will have to write less. So step 1, n when divided by 7, the remainder is 3. So can I write n as 7p plus 3? Any number which is in the form 7p plus 3 when divided by 7 will leave a remainder of 3. Forget the other divisors, only focus on 7 and remainder 3. So what are such numbers? I can take 3. When you put p0 I get 3, you put p1 I get 10. 10 को भी देखो 7 से divide करके remainder 3 आएगा. Then you put p2 I'll get 17. Similarly 24, 31, 38, 45, 52, 59 and so on till infinity. There are infinite such numbers. So n जो अपना number हम calculate करने के लिए try कर रहे हैं, it is one of them. Okay, but we have just applied one filter, तो सारे natural number से कुछ numbers filter होके आ गए. Now we'll go for the next filter. That is step 2. तो ट्राई एंड अंडरस्टैंड, हम स्टेप बाय स्टेप फिल्टर आउट कर रहे हैं एंड फाइनली विल रीच आवर डिजायर्ड नंबर. कैसे फिल्टर आउट कर रहे हैं? बाय अप्लाइंग द प्रॉपर्टीज. पहला प्रॉपर्टी अप्लाई किए, नेचुरल नंबर्स में कौन से नंबर्स डिवाइडेड बाय 7 लीव्स अ रिमाइंडर 3. देन द नेक्स्ट प्रॉपर्टी विल बी द नेक्स्ट हाईएस्ट डिवाइजर. So step 2, when divided by 4, the remainder should be 1. Now instead of going again back to the natural numbers, I'll check out the steps here. The numbers that I got by filtering in step 1, उसी में से check करेंगे which numbers when divided by 4 will give me a remainder 1. तो देखते हैं क्या क्या numbers है. तो पहला number तो आ गया 17. Then next number if I check, when divided by 4 it is leaving a remainder 1, 45. 17 and then 45 again. And interesting, you see the gap between 17 and 45 is 28, and 28 is basically the LCM of 4 and 7. Why I am saying this? Let's come to this. So in step 2 my first number is 17 and the second number is 45. I can't keep writing all the numbers and then try and see gap kahan pe aa raha hai. So this is a definite pattern. All I need is the first number, and the second number will automatically come after a gap of the LCM of the divisors that you have considered. So I have considered divisor 4 and considered divisor 7. So 4 and 7 का LCM is 28. So automatically my subsequent numbers 28, 28, 28 के gap में आएगा. तो मेरे को लिखना नहीं पड़ेगा इतना numbers, बस पहला number चाहिए. 17, 45 आ गया. फिर 28 ऐड करो, I'll get 73. Then 28 add karo, I'll get 101, then 129 and so on till infinity. Just keep adding 28. Now all these numbers when divided by 7 leave a remainder 3, when divided by 4 leave a remainder 1. So last step is when divided by 3 the remainder should be 2. So again don't go back to all the natural numbers, check in the second step. Which numbers in step 2 when divided by 3 will leave a remainder 2? So first number is 17. So let us write 17. Also look at the second number. Second number will be 101. But even if you have not written the second number, we don't need that also. Just पहला number लिख लेना है. Second number automatically उसी pattern में will come after a gap of the LCM of all the divisors, because I have considered all divisors now. And 347 का LCM is 84. तो 17 plus 84 देखो अपने आप 101 जो second number. Even if तुमने step 2 में उसको नहीं लिखा होगा, you will get that. You don't have to write all the numbers. Then the next number will be 185 and so on till infinity. So all these numbers that I got in step 3 when divided by 3 leave a remainder 2, when divided by 4 leave a remainder 1, and when divided by 7 leave a remainder. This process is called Chinese remainder process. There is another way to look at Chinese remainder theorem. I have done a video on Chinese remainder theorem. You can go to my remainders playlist and watch that. This is also another way to look at the same thing. Multiple divisors, multiple remainders होगा तो इसी process में हमको follow करना. मैंने 3 divisors लिया. Usually 2 divisors and all में questions आ जाते हैं, which is easier than this to solve. But then this is a good exercise. If we deal with 3 divisors, obviously we'll find it easy to deal with 2 divisors. Now there is this pattern. So you see every subsequent number 84 is getting added. So that means I can write n is 84k plus 17. So when you put k as 0, you will get 17. You put k as 1, you get 101. K as 2, you get 185 and so on. Now if the number is in the form 84k plus 17, what was the question? Largest 3-digit number. So I'll again go back to the same 999. We had calculated it is 84k plus 75. I need 84k plus 17. So 75 से 17 जाने के लिए I'll have to take a minus 58. So I'll do a minus 58 on this side also. So 9, 9 minus 5, 4, 9 minus 8, 1. So 941 is our answer. So understand the model. This part that we're doing largest 3-digit number, that will vary from question to question. Maybe how many such 3-digit numbers are possible, या largest 4-digit number, smallest 5-digit number, तो कुछ भी पूछा जा सकता है. But 84k plus 17 is where we should come and then think about next step. I hope this part is clear. Very easy. Start with the highest divisor, highest remainder, and gradually put filters. And the obvious thing to keep in mind here is the subsequent numbers का gap क्या क्या आ रहा है. तो पहले स्टेप में सारे नंबर्स का गैप हुआ 7 because I had considered only one divisor, that is 7. सेकेंड स्टेप में सारे नंबर्स का गैप इज 28 because now I have considered two divisors, तो उनका LCM 4 and 7. थर्ड में सब सारे नंबर्स का गैप इज 84 because थ्री divisors 3, 4 and 7, तो उनका LCM. LCM is the gap. So once I understand that gap, then there is nothing much difficult about this model. So multiple divisors, multiple remainders. This is model 3. Then coming to the final model, model 4. ये गलती से 3 लिख लिया. This is model 4. Model 4 is successive division. Successive division. Find the largest 3-digit number which when successively divided by 3, 4 and 7 leaves a remainder of 2, 1 and 3 respectively. Now previous 3 models were simultaneous division. This one is a successive division. What's the difference? Now you look at any of the previous models. Every time you were dividing, n was divided by 3, n divided by 4, n divided by 7. वही number को बार बार divide कर रहा है. But successive division में क्या होगा? Let's say our number here that we are trying to calculate is n. So first I'll divide n with 3. We don't know the quotient. Let's say it is q1. The remainder is 2. In the next step, I'll not divide with 3. My divisor becomes 4. But n, instead of dividing n, I'll divide the result of the first step here. That is why it is called as successive division. Like the divisions are linked. Previous models में divisions were independent. N divided by 3, n divided by 4, n divided by 7. But here n divided by 3, the quotient is next divided by 4. Let us say the quotient now is q2, the remainder is 1. In the third step, I will divide the quotient of the previous step. So this is divided by 7. Let's say the quotient is k and the remainder is 3. This is what is called as successive division. Successive division. Now, very simple process to solve this also. I'll only use this simple property, that is dividend is divisor into quotient plus the remainder. Now all of us know this. बस इसी को use करना है. Trick is I'll start from the end. Let's look at Q2. Q2 is the dividend. Can I write Q2 as 7k plus 3? Divisor into quotient plus remainder. This is Q2. Now Q1 is 4 times Q2. 4 times Q2 plus 1. This entire thing is Q1. And the number n, if you look at, it is 3 times Q1. This entire thing is Q1. 3 times Q1 plus 2. So this is my number. Simple. I'll just start from the end. Dividend is divisor into quotient plus remainder. You see, it's not always about formulas. इसका भी एक shortcut है, I'll discuss. But then our fundamentals should be clear कि successive division है क्या, फिर उसको approach कैसे करें. If our fundamentals are clear, we don't have to memorize it. बिना memorize किए proper understanding के साथ we can approach the question. But हाँ, with practice and shortcuts, we'll gain speed. But then those things won't mean anything if our fundamentals. तो ऐसा क्यों कर रहे हैं, वो ऐसा क्यों रिजल्ट आया, प्लस कब कर रहे हैं, माइनस क्यों कर रहे हैं, ऐसा इस प्रोसेस में क्यों फॉलो कर रहे हैं, दैट व्हाई पार्ट इज वेरी इंपॉर्टेंट. नाउ इफ आई एलैबोरेट दिस स्टेप, n is 3 times, let's open the bracket, 4 into 7, it is 28k plus 4 into 3, 12 plus 1, I get this 4 into 3, 12 plus 1, 13 plus 2. Now 3 will be multiplied, so I'll get n as 3 into 28, 84k plus 3 times 13 is 39 plus 2, 41. I'll get this. Just to cross check, is it working or not? Check कर लेते हैं. 41 when divided by 3, the remainder is 2. Then 13 when divided by 4, the remainder is 1, and then 3 when divided by 7, the remainder is 3. So successive division it works. Again, look at something interesting. That's the reason I deliberately took the same devices in all models. So तुम देखो बार बार 84k is always coming. So when you read this question, number when divided by 3, 4 and 7, तो automatically माइंड में इतना तो आ ही गया कि मॉडल है तो 84k तो आएगा, बिकॉज 3, 4, 7 का एलसीएम है, तो सब्सिक्वेंट नंबर्स 84, 84 गैप में हमेशा आ रहे हैं. All I need is the first number. So here comes the shortcut. If somehow I can figure out the first number easily, तो 41 plus 84k looking at the devices I can write. यहाँ पे 3, 4, 7 है इसीलिए 84k हो रहा है. Any other devices you take accordingly उनका LCM into k will be added. But shortcut के लिए what you do is you write the divisors and the remainders horizontally. 3, 4 and 7, 2, 1 and 3. Once you have written horizontally, ignore the last divisor and start with the last remainder. Now diagonally multiply, vertically add. Diagonally multiply, vertically add. तो जब diagonally जाओगे multiply, vertically add, you will directly get 41. ऐसे देखो 3 into 4 is 12 plus 1 13 into 3 39 plus 2 41. So directly this gives us 41. So I can write n is equal to 84k plus 41. So this is a shortcut to get this number 41. बहुत easily तुम्हें ये number मिल जाएगा and फिर 84k. So you can skip this to dividend equal to divisor into quotient plus remainder. वही आंसर आएगा, but this is a shortcut to quickly get the number 41. Now once we have got 41 or 84k plus 41 हमें model मिल गया. What is the question again asking? Find the largest 3-digit number. Again we'll go back to the same. 999 is the largest 3-digit number, but that is in the form 84k plus 75. If I want 84k plus 41 के form में number में, so 5 minus 1, I need to subtract a 34. So 34 RHS में if I have subtracted, I'll subtract it in LHS. 9 minus 3 6, 9 minus 4 5. So 965 is of the form 84k plus 41 and that is our answer. Any number which is in the form 84k plus 41 should satisfy this condition. 965 is our answer. So this is successive division. These are 4 types of questions in LCM models and I hope all of you understood each of the types. Multiple divisor, multiple remainder, multiple divisor, same negative remainder, multiple divisor, same remainder, which is same positive remainder, and finally successive division. 4 types, 4 LCM models we call this. Model means basically type of question. So hope all these 4 models are clear. So I have given 4 sample questions from each of the models for you. So I have given the options here also. Do try out these 4 questions and answer, like comment your answers in the video. Each question ka individually solve karo and let me know your answers in the comment section. And if you find anything difficult also, let's discuss in the comment section, and hope you understood all the models properly. So that is it from my end for this video, and in the next video I'll be discussing HCF models as well. So thanks again for watching, and if you are new to the channel and you have watched this video for the first time, once again do subscribe to the Aptitude Club channel and watch my other videos on quants as well as LRDH. So we'll meet again in another session. Till then, have a nice day all of you. Bye bye.